Hello everyone, this is Mike Seitz, and this is the FAA Part 107 Remote Pilot Study Guide that has been carefully developed and intentionally designed to give you the maximum amount of understanding. We're talking about those of you who are interested in getting your FAA drone certification. This is the video you need to watch. I'm going to push you to the highest level of comprehension so you can get as close as possible to that 100% passing score. I'll be going over everything from A to Z with clear, detailed explanations so you understand exactly why these answers are correct. And just for your convenience, I have placed chapter timestamps for every single topic that we'll be discussing. So here we go, jumping right in. Part 107 Study Guide for 2026 through 2027. Let's go. Now, the first two questions that need to be answered is, who is the FAA and what exactly is Part 107? Those are relevant questions to ask if you're studying for the FAA Part 107 exam, don't you agree? The FAA, or Federal Aviation Administration, is the United States government agency responsible for regulating and overseeing all civil aviation within the United States. So what does this all mean? And as you can see, I'll be posting questions on screen throughout this video to keep you all engaged. Civil aviation refers to all non-military aviation activities. And what I mean by that is for commercial purposes, private recreational flying, training, transportation, aerial services. In simple terms, if an aircraft is not operated by the military, it falls under civil aviation. This is the FAA's primary purpose, safety in regard to civil aviation. So, the next question. What is Part 107? Well, Part 107 is the section of the Federal Aviation's rules and regulations that govern commercial operations of small unmanned aircraft systems, or sUAS. Get used to that acronym. sUAS is the abbreviation for Small Unmanned Aircraft Systems in the United States. And break it down just a little more. What exactly is an sUAS? Well, it's a drone, because a drone is a very small aircraft that doesn't have a person sitting in it to operate it. The person who's operating the drone is operating it externally away from the drone with a remote control. That makes it a small unmanned aircraft system. And for the FAA, anything that is under 55 pounds or less than 55 pounds is considered as a small unmanned aircraft system. So going back to Part 107, which is the section of the rules and regulations, they only pertain to small unmanned aircraft systems or drones. So now you can see that since drones have been introduced into the national airspace system within the United States, the FAA had to come up with a rule or regulation or section to govern these drones that are flying around in the national airspace as unmanned aircrafts, and that section is Part 107. And Part 107 is within the Code of Federal Regulations. Now, within the Code of Federal Regulations, there are other sections or other parts, such as Part 91, which applies to private airplanes and pilots, Part 135, which applies to charter flights, Part 121, which applies to the major airlines like Delta, United, American Airlines, Southwest Airways. But we are only specifically concerned about Part 107 because that is the only part that applies to drones or small unmanned aircraft systems. Now, there is a book that I consider as being the Bible for regulations and aviation, and that book is the F.R.I.A. So the interesting question here is, when did they actually introduce Part 107 into the F.R.I.A.? And that date was August 29th, 2016. This is all relevant because it gives you a timeline to understand about Part 107. Now, for those of you who want to pick up this book, well, you can click the link in my video description, and that will take you to where you can actually purchase this book. Now let's talk about the two scenarios of whenever you're flying a drone, either for fun, recreationally, or you're flying a drone for business to make money, commercially. Now, if you're flying a drone for fun or personal enjoyment, That is a recreational pilot, and you are not required to have a Part 107 certificate, so therefore, you don't need to take this exam. Recreational hobby pilots are not required to be Part 107 licensed, but they do need to take and pass a safety test called the T.R.U.S.T. It's a test that recreational flyers can take online, and it's absolutely free, but it is mandatory and it is required that you must have a T.R.U.S.T. certificate before you can fly a drone recreationally. Now, why is it that no one else tells you that? The FAA requires that you pass the T.R.U.S.T. test and print out the certificate, and basically, no certificate equals no legal flight. You cannot fly a drone if you are a recreational flyer without passing the T.R.U.S.T. test first and printing out the certificate, and that certificate must be on your person, held by you at all times when you're flying a drone recreationally. Violations of this mandatory requirement means that you may have a warning, a fine, or even be ineligible for future Part 107 certification. Very important information I'm giving you here. Now, commercial operations are flights that are conducted for compensation or business purposes. For example, this could include aerial photography for real estate, aerial inspections or surveys, shooting a wedding with your drone and getting paid for it, doing someone a favor by taking aerial videos of their home so that way they can in turn repay you by babysitting your children. All of that is considered as commercial operation, and for that, you will need a remote pilot certificate under 14 CFR Part 107. Now, let me give you a scenario which you may think is an exception to the rule. Let's suppose that you're out with your family on a picnic and you're all having a great time, and you decide to put your drone in the air so you can record videos to capture all of the memorable moments. And then when you get home, you decide to put it on your YouTube channel. The question here is, does posting a fun drone video on your YouTube channel make it commercial? That's a very good question, isn't it? Well, the answer to that question, according to the FAA, is it depends on the intent. Remember that word, intent. If you fly your drone purely for fun and later decide to upload that video to your YouTube channel with no monetization, no promotion, no business purpose, then the FAA generally considers that as being a recreational flight. However, if the video has ads or revenue sharing or the channel is monetized, then the FAA considers that video as being a commercial operation. And therefore, the FAA considers that the intent was to benefit you financially, either directly or indirectly. So when you're flying, it's important for you to understand what your intentions actually are. So let's move on and talk about the remote pilot certification process. First, let me make note of this. I know that a lot of you have already booked the date for your exam before you have even had a chance to watch this video. That may either be a good move or a bad one, depending on how fast you can learn the material. You see, this is not about memorizing the answers to the test. This is about having complete and total comprehension and understanding, so that way you would be able to, in essence, teach the course yourself. Now, in order to be eligible for this exam, you need to be at least 16 years of age. You need to be able to read, speak, write, and understand English. And the one just below says be in physical and mental condition to safely fly a drone. Now, I'm wondering, how did they know that I was in such excellent physical and mental condition to fly? Well, anyway, the last one says that you must pass the initial aeronautical knowledge exam. Now, let me clarify the eligibility for what I just said. There are no examiners interviewing you medically or mentally. When you apply to take this exam, you are certifying, legally attesting that you meet the requirements under 14 CFR Part 107.61. So saying that you're 16 years of age or older, English proficiency, no physical or mental condition that interferes with the safe operation of a drone, that is a legal statement, not a formality. Now, for the Part 107 exam, there are a few things that you need to do first before you actually sign up or register to take that test. You'll need to go to the IACRA website to obtain a tracking number or an FAA tracking number, FTN, and that is what the FAA will use to verify your score on the Part 107 exam, whether you pass or failed. And you know that after watching this video, you're not going to fail, right? And you also have some information on my website at mikesites.com. Now, the Part 107 exam is administered in person, meaning that you cannot take this test online. It will have 65 questions with multiple choice answers A, B, and C. And you must score a 70% or better to pass this exam. You will have a 2-hour limit to take this exam, but don't worry, that's more than enough time. If you understand and know the information, you will not need 2 hours to pass this test. Now, those of you who have not taken the exam yet are probably asking yourself and saying, I thought it was supposed to be 60 questions on this exam. Well, it is 60 questions on the exam, but the FAA just included 5 more, so bringing the grand total to 65 questions. So for all of the other study guides that you're watching that say 60, no more. It's 65 questions on the exam. So don't just rush in and schedule your exam date yet. You have 5 more questions that you got to worry about. When you're confident and you know that you're ready to take this exam, you'll be able to go to the PSI website and choose an FAA-approved facility near you where you can walk in and take the exam. Now, after passing the exam, you will go through a process of background check with the TSA, and then you will receive your plastic card, your remote pilot certificate, in the mail. The physical plastic card that you receive in the mail, your remote pilot certificate, will have a date of issue on it, but it will not have an expiration date on it. You'll need to know that you must renew that card every 24 calendar months. Now, another question that came up on the Part 107 exam was about a name change. And for years, we've primarily only been focusing on an address change, which requires you to notify the FAA within 30 days. We're going to break that down in just a second. But as you can see, I have the code up, 14 CFR Part 107.77 for change of name or address. And you can see here that whenever you're making a change on the remote pilot certificate, you will need to have a copy of the marriage license, a court order, or a document verifying the name change before you can actually initiate that change. And in regard to the change of address, well, once you actually move in to the new location or the new address, then at that point, day 1 begins. You have 30 days to notify the FAA of the address change after you have moved in, not while you're planning on moving in, but after you've moved in to your new address. Then the clock starts running. You have 30 days to notify the FAA of the change of address. Now, let's go back and clarify something that is very confusing sometimes based on the questions that I've been receiving in my comments. Whenever it is that you're hearing 24 months, it's referring to the renewal of your pilot certification. But whenever it is that you hear 3 years, it's referring to the registration of your drone. Don't confuse the word registration with certification. They're 2 separate things. Registration, which is what we're on right now, has to do with your drone, and you need to register your drone every 3 years. This will be on the Part 107 exam. And more than likely, you will get this question wrong if you think of certification. Now let's discuss FAA rules and regulations and focus on you, the Remote Pilot in Command, or RPIC. You see, the Remote Pilot in Command is the person who is directly responsible. That word responsible you will see over and over and over again, and in any time you see that word responsible, it is referring to the Remote Pilot in Command who, under 14 CFR Part 107.19, is responsible and holds final authority for the entire operation of the flight, even if another person is physically controlling the aircraft. From what I understand about the recent exams being taken, the FAA is focusing their attention and their questions on the Remote Pilot in Command. Now, speaking of questions, there is a new question that you may not be aware of, and that is, how many drones can a remote pilot fly at one time? This falls under 14 CFR Part 107.35. And to break this down very simply for you is only one remote pilot, then only one drone. So all of you who have been flying 2, 3, 4 drones all at once and showing it on YouTube, well, guess what? You're breaking the law. And that's not coming from me. That's coming from the FAA. Now, there is someone else who has a certain level of responsibility, and that person is called a visual observer, or VO. This is the person who will assist the remote pilot in command, but does not have authority over the flight. Only the remote pilot in command has legal responsibility. Some key points here. The VO must be in constant, effective communication with the remote pilot in command to ensure safe operation. The visual observer is the person who maintains visual line of sight, or the acronym for that is VLOS, visual line of sight. That is the responsibility of the visual observer. Now, here's a very creative or sometimes confusing question. Let's say the remote PIC, or the remote pilot in command, passes out and loses consciousness, and the visual observer takes control of the drone. Can that visual observer operate that drone if they're flying a commercial operation? Isn't that just a great question in regard to this particular scenario? Think about that question for a moment. And here's the answer. The answer is no. The VO cannot assume control of a commercially operated drone because that VO is not licensed. The only way that that visual observer would be able to maintain and assume control is if that VO has passed the Part 107 exam and has a remote pilot certificate. Now let's talk about the control station, or CS for short. The control station is a physical location where the equipment that is being used to control the drone is located. More explicitly, the control station is the remote control located at a certain point. It is where the pilot is standing to maintain control and also maintain situational awareness. You will see this term control station, or the acronym CS, on the Part 107 exam, so you need to know what that means. Now let's go according to the Code of Federal Regulations 14 CFR Part 107.3, which states the control station is defined as the interface used by the remote pilot to control the small unmanned aircraft. Now, we're still within the FAA rules and regulations, so let's talk about the maximum allowable altitude. Under Part 107 rules, regardless of whether you're flying commercially or you're flying recreationally, you can only fly up to 400 feet above ground level. And ground level doesn't mean when you're standing on the roof of a man-made building. Ground level is where the foundation of that building is located. And from that point, you can only fly 400 feet maximum altitude. But the FAA says if you are within 400 feet distance from that building, then you can fly 400 feet above the top of that building. And of course, you're within 400 feet because you're standing right on the roof of that building, right? So here's the question for you. If the building is 400 feet high, then how high can you fly according to FAA rules and regulations? And I know a lot of you just figured that out instantly, didn't you? Yes, you're right. The answer is 800 feet AGL, or 800 feet above ground level. So here's the reverse explanation. Under 14 CFR Part 107.51b, a small UAS may not be flown higher than 400 feet above ground level AGL unless it is flown within 400 feet radius of any structure. Now, you remember when I said that I designed the study guide for full comprehension, so I'm going to ask you a question based on a scenario. Let's say that you're flying your drone recreationally, and you're a recreational pilot, and you have a building in front of you that is 400 feet within your distance. So you're within 400 feet of the building, and you're a recreational pilot. Are you able to fly 400 feet above that building? Yes or no? That's a very simple question, isn't it? But the answer is not very simple unless I explain it to you. And sometimes my explanations are rooted in the form of a question. So let me ask you this question. Why are you getting this remote pilot certification in the first place? And that's because you want to have privileges that ordinary people flying drones simply do not have. And one of those privileges is your ability to fly over 400 feet AGL when you are within 400 feet of any structure. A recreational flyer who has not passed the Part 107 exam and who is not licensed cannot fly above 400 feet even if they're within 400 feet distance of a structure. Now, in regard to an in-flight emergency, could this be a reason why a recreational flyer can deviate from Part 107 rules and regulations and fly above 400 feet to avoid an emergency situation, such as an oncoming aircraft? And some of you Sharpies are saying, wait a minute, did he just say recreational flyer flying under Part 107 rules and regulations? Ding ding, I just gave you an FAA underhanded trick. Recreational flyers don't fly under Part 107, therefore they cannot legally deviate from the 400-foot AGL rule. During an in-flight emergency, the only pilot that is allowed to deviate from Part 107 rules and regulations is a remote pilot that is certified. An in-flight emergency is an unexpected reaction to an emergency situation that's happening I call exigent circumstance, and a remote pilot in command who is certified has the right to be able to deviate the flight path and break the 107 rules and regulations to avoid a collision. A recreational flyer does not have the legal authority to exceed the 400-foot rule, even in the event of an emergency. So the only decision that you can make when you're trying to avoid an in-flight emergency as a recreational flyer is to descend and land the drone as safely as possible. Now, a certified remote pilot in command does have the legal capacity to make those decisions when it's about exceeding the 400-foot rule and breaking or deviating from the FAA Part 107 rules and regulations. Now, here's the thing you need to remember for the Part 107 exam. In an emergency situation or an in-flight emergency, you do not need to report this to the FAA. You can continue flying and doing what you need to do without the need to report the incident to the FAA. But, and you knew that but word was coming, didn't you? If the FAA is making a request in regard to the emergency deviation and they're requesting that you submit a report, then you will need to submit the report. It's kind of like if you were driving and you swerved over to the right on the sidewalk because you had to avoid an animal crossing the street, and a police officer pulled you over and asked you, why did you do that? Well, it might be a good idea to let him know within 10 seconds, right? But with the FAA, you need to report it within 10 days. Now, since we've touched on in-flight emergency and the reporting period, let's talk about a new question on the FAA Part 107 exam that you won't really see too much on other study guides, and that has to do with hot air balloons. Now, before I dive into this, let me ask you two questions. Is a hot air balloon actually an aircraft? And the second question is it manned? So, I'm speaking of a manned aircraft, which we know so well because we just discussed in-flight emergencies. But is a hot air balloon actually an aircraft? You see, the value of this video actually shines through because you would not be able to answer this question if you were focusing on 14 CFR Part 107. The only way you'd be able to answer that question is if you were shifting your focus towards 14 CFR Part 1.1, which has the definition of an aircraft that means a device that is used or intended to be used for flight in the air. So since you now know that a hot air balloon is actually an aircraft, now you just need to understand that since there is someone sitting inside of that hot air balloon, that it is considered as being a manned aircraft. So here is the new unexpected question you're going to see on the Part 107 exam. A remote pilot observes a hot air balloon approaching the operating area. What action is required? Is it A, continue the operation because hot air balloons have limited maneuverability? Or B, yield to the right-of-way and maneuver the small unmanned aircraft to remain well clear? Or C, ascend above the balloon to avoid a collision? Now, I could just remain surface level and just tell you what the correct answer is, but I want to develop your skills. You see, previously before I mentioned 14 CFR Part 107.37, which has to do with the right-of-way rules. So if the FAA is continuously using these words, then there's no way that they would put right-of-way into the wrong answer. So the correct answer is B, yield the right-of-way and maneuver the small unmanned aircraft to remain well clear. Now, since we're on the right-of-way topic, let's talk about it just a little more. And remember this, all manned aircrafts have the right-of-way over a drone. And what right-of-way actually means is the yielding, giving way, complying. But as for the FAA, this action of yielding or giving way is not something that is passive. It is something that the FAA expects you to react with immediate action. For example, you see a helicopter or an airplane, a glider or a hot air balloon coming at you. It's coming towards you. Well, the immediate action is to alter course immediately, to descend immediately, to climb to a safe altitude immediately, to land immediately if necessary. This is the type of right-of-way action that the FAA is actually referring to. And I'm giving you this information because no one else will. It's important that you understand what right-of-way actually means according to the FAA. Simply hovering your drone passively and calmly waiting for the manned aircraft to go by is not going to cut it. You need to take immediate action, and that is what the right-of-way rule means. Now, the same 10-day requirement for reporting an in-flight emergency to the FAA is also the same 10-day requirement for reporting an incident to the FAA which involved seriously injuring another person that resulted in hospitalization or damage to property that was over $500. Now, let's talk about injury first. If your drone injures someone and it's a serious injury, such as they're unconscious or they needed to be rushed to the hospital or one of the propellers severed their left foot, the FAA would classify that as a serious injury, wouldn't you? In that instance, it needs to be reported to the FAA within 10 days. And if it's a minor scrape or bruise or something of that nature, which is considered as being minor, then it does not need to be reported. Now, here's where I break it down for you, just as I always do, because a question came up as, Mike, what about if the drone causes serious injury to the remote pilot? Well, I'm going to tell you, if I severed my own left foot with my own drone, well, I'm not going to report it to anybody because I'd be too embarrassed, right? But the fact of the matter is that under 14 CFR Part 107.9, you must report no later than 10 calendar days serious injury that occurs to any person. A certified remote pilot is not exempt. Now, in regard to damage, I want you to do something for me. Go look at the notes you've been taking from the other study guides you've been watching and tell me, what did you put down as the amount for damage to property and reporting that incident? I don't need you to answer that because I already know what that number is. You wrote down $500 is when you needed to make a report to the FAA. That's what you have been fed from the year before that, and the year before that from the study guides. But that is not correct. According to the Code of Federal Regulations 14 CFR Part 107.9, B. According to that, you don't need to make a report when it's $500 damage. You need to make a report when it's over $500 or more than $500. So, for example, $500 and 1 penny. You need to make a report. Let me explain to you why it is that everyone else seems to be getting so confused about this $500. It's because whenever you're reading the code, it's written in sort of a legal language. So let me just summarize this whole thing for you. You see, whenever it is that they're looking at the $500, it says does not exceed. So you automatically think that they're saying $500 or greater. Look at the key words. It says you need to report it unless it does not exceed $500 or greater. And it's still a little bit confusing, right? But the fact of the matter is, the correct interpretation of this is that anything over $500 is when you need to report it. The The FAA just wrote this backwards, so everyone else is getting confused. But don't worry, this is why you have me to break it down for you. Moving to the next one, maximum allowable speed. This is 14 CFR Part 107.51 in regard to the maximum ground speed of a small unmanned aircraft. Now, here's another breakdown example. What exactly does ground speed actually mean? Well, it has to mean something because ground speed is not the same as airspeed. And I can tell you what the differences are right now. You see, ground speed is measured relative to the ground, such as miles per hour or even knots. But airspeed is not measured in that way. Airspeed is measured relative to the surrounding air. So for example, if a plane is traveling at 30 miles per hour in the air, and there is a strong headwind that's pushing against that plane at 10 miles per hour, then in actuality, the plane would only be traveling at a ground speed equal to 20 miles per hour. So the FAA's maximum allowable speed for a drone will always be measured in ground speed. Now let's go over what those speeds actually are. A small unmanned aircraft may not exceed 87 knots, which is equal to 100 miles per hour. This is a ground speed limit, and this speed is relative to the ground, as I mentioned. And the way that you know exactly how fast your drone is going is because your drone has something on board that you have in your car, and that's a GPS. The GPS will tell you how fast you're going, 50 miles an hour, 60 miles an hour. Well, a drone has a GPS built in also, and it will tell you on your remote control, you will see it, that it says certain miles per hour. That is the speed that you're traveling in the air for your drone based on GPS. Now, moving on to weight limit in regard to registration. Under 14 CFR Part 107, a small unmanned aircraft system must weigh less than 55 pounds at takeoff. Now, this is including anything that you have strapped on board that aircraft. It doesn't matter what it is that you have on that aircraft. It could be some additional components or something that you need to complete the operation, such as anti-collision lights, whatever it is. If it adds to the weight of the drone upon takeoff, and that weight is more than 55 pounds, it will no longer apply to Part 107. It will fall under some other section. So the most important thing to remember is that in order to maintain compliance under Part 107 rules and regulations, the drone, upon takeoff with everything on board, must weigh less than 55 pounds. Now, in regard to registration of the drone, as long as it weighs less than 55 pounds, you can register the drone with the FAA under Part 107. But if it weighs more than 55 pounds, you cannot register the drone under Part 107. Now, on the flip side, let's talk about a very light subcompact drone that weighs, let's say, 250 grams. Any drone that weighs 250 grams or more must be registered with the FAA. And you've already seen subcompact drones that have 249 grams stamped on them, right? And that's because anything that weighs less than 250 grams does not need to be registered with the FAA. A subcompact drone weighing 249 grams is usually what a recreational flyer would want because they tell you that you don't need to register it with the FAA. But if you have something strapped on board, that 249-gram drone, and it puts it at 250 grams or over 250 grams, then you need to go register that drone with the FAA. So to clarify this whole thing, if you're a commercial pilot or a recreational flyer and you have one of these three criteria, then registration is required. Now, let me tell you something that has been so confusing, and we didn't confuse it, the FAA did, and I'll tell you the reason why. You see, back in the old day, grams were not used for drone weight. It was always in pounds. And just so you know, the drones I'm referring to back in the old day were not what you're looking at on the screen. It was these big, giant monstrosity drones made in the United States. So when the foreign drones started coming into the country, they had gram weight stamped on them because they were using the metric system, not pounds. So what did the FAA decide to do? Well, they got one of their lawyers to rewrite the code, the statute, to include gram weight as 250 grams, for example, and they goofed up the articulation, whereas everyone now thinks that 250 grams is equal to 0.55 pounds. So let's go over the articulation for what is written on the FAA website. All drones must be registered except those that weigh 0.55 pounds or less, and then it says less than 250 grams and are flown under exception for limited recreational operation. Now, I don't know who wrote this. Maybe some attorney had a little bit too much to drink because the way it is articulated makes it confusing. This is the reason why most people, even content creators, do not understand this 100%. So let me break this down in a way where it is understandable. So here is my clear and corrected version. All drones must be registered unless they weigh less than 250 grams and are flown under exception for limited recreational operations. Or I can say it the other way. All drones must be registered unless they weigh 0.55 pounds or less and are flown under the exception for limited recreational operations. Those two things that I just said make it perfectly clear that in order to avoid registration, the drone must weigh less than 250 grams or it must weigh 0.55 pounds or less, because 0.55 pounds does not equal 250 grams. So FAA, if you're watching this video, you can make these changes on your next publication, and please, please, don't allow the lawyer to drink and write at the same time. Now, in regard to the person who is registering the drone, that person must be at least 13 years of age in order to register a drone with the FAA. Remember that. 13 years of age is the requirement. If you're under 13 years of age and you want to register a drone, you'll just have to find someone who is 13 years or older to register the drone for you. And lastly, if you want to register a drone, all you need to do is to go to FAA DroneZone and you'll be able to register your drone. Now remember, if you're a recreational flyer, you only need to register once and you can fly all of your drones under that registration for recreational flyer. It's valid for 3 years. But if you are a Part 107 commercial pilot, you must register each and every drone individually, and each registration will cost you $5. Each registration is valid for 3 years. Now, let's clear something up right now in regard to the registration number that you're going to receive for your drone. A commercial operator will be issued a registration number that must be affixed to the exterior of the aircraft. Under 14 CFR Part 48.205C, the registration number must be affixed to the aircraft. It must be legible and it must be maintained in a condition that is readable. Now let's move to a very big topic on the Part 107 exam, and this has to do with remote ID. And before I actually go into the requirements for remote ID, I need to explain to you exactly what remote ID is. Remote ID is a broadcast, and you'll hear everyone say that it's a digital license plate for a drone. Okay, whatever. But I'm going to break this down for you so it's clear and understood technically. As of March 16th, 2024, and that's very recent, the FAA requires that all drones that weigh 250 grams or more must have remote ID built in. They must be remote ID compliant. This is why a lot of the older study guides that you've been viewing don't even mention remote ID, because it didn't come about until 2024. Drone manufacturers who are building new drones all know that it is a requirement that if the drone that they're building is 250 grams or more, that they must have built-in remote ID, or what is called standard remote ID. I want you to please remember what I just said. Standard remote ID. Whenever you see those words on an FAA Part 107 exam, what they're referring to with standard remote ID is a drone that has remote ID built in. It already has the chip and the transmitter built into the drone, so it's automatically transmitting a remote ID broadcast frequency. Now, this frequency that's being transmitted is an approved broadcast frequency that is transmitting on Wi-Fi 2.4 gigahertz and 5 gigahertz frequency band. These are very common Wi-Fi frequencies. There's nothing exclusive about it. But what exactly is being broadcasted? That's the next question. And the question after that is, who exactly can receive these broadcasts coming from the drone? And another question after that is, will all my personal information be open and visible to the public? Well, I'm sure these are questions that you have, and all of this is a learning process in regard to complete comprehension, as I mentioned. So understand this. Remote ID broadcast is a pulse. It is pulsing a broadcast 1 pulse per second. And the information and data within each pulse is changing as the drone is moving, changing altitude, as it's going faster or slower, or it's descending. The drone's GPS is providing information that is being broadcasted, such as latitude, longitude, altitude, horizon speed, ground speed, vertical speed, heading, direction of flight. All of these things are being pulsed and broadcasted in remote ID. And it's also providing information as to where the remote pilot is located with the remote controller at the control station, CS. Do you remember that from the earlier? And each pulse that's broadcasting information also has a timestamp on it for Coordinated Universal Time, UTC time timestamp. Now, what's not being broadcasted is your personal information, such as the name of the pilot, the address and phone number of the pilot's firstborn child, or the pilot's favorite dog. Those things are not being broadcasted. It's only what's pertinent in regard to the drone information and its particulars. Now, each remote ID will have its own unique serial number, and that serial number also needs to be registered with the FAA when you're flying commercially or even when you're flying recreationally. Because remember, any drone that weighs 250 grams or more, regardless of whether you're flying it recreationally or whether you're flying it commercially, needs to be registered. And if that drone has remote ID built in, as standard remote ID, then the serial number of the remote ID is what needs to be given to the FAA upon registration. So now let's talk about a drone that does not have standard remote ID built in, or an older drone that was built or manufactured before remote ID was even invented. So the question here is, what do you do if you do not have remote ID on your drone and you plan to fly that drone? Well, the answer is very simple. Simply get an external remote ID module and stick it onto your drone so it will broadcast remote ID. A remote ID module is a very small, cost-effective little external device that you just put onto your drone, and it will broadcast remote ID, and that's what you will register also with the FAA. Older drones do not have remote ID built in, so you'll need to purchase a remote ID module. Now, here's an interesting question. If you have a drone that weighs less than 250 grams, then you should all know by now that remote ID broadcast is not required. That is, unless you are flying that drone commercially in a commercial money-making operation. But let's say you have a drone that weighs more than 250 grams, remote ID is required. If you're flying an older drone that weighs more than 250 grams, the question here is, where can you fly that drone without having remote ID? And all of you probably just thought of the same thing instinctively, right? Nowhere. But there is one place that you can fly the drone without remote ID, and that place is called a FRIA. F.R.I.A. The acronym FRIA stands for FAA Recognized Identification Area. This is a place where geographically it is defined as an area where drones can be flown without broadcasting remote ID. It's a place that's used for recreational flyers or clubs or organizations that are trying to have instruction on drone flight. Usually you'll find a group or an organization that's in charge of or authorized to utilize that area. And it's not necessarily a place that you can just drive up to and then park your car, get out with your drone and start flying and saying, hey, I'm going to fly my drone in a FRIA today. It doesn't really work that way. It's more of an organizational-based type of thing where the FAA is utilized for organizational, club, recreational purposes. The key thing to remember about a FAA for the Part 107 exam, write this down, is that any drone flying within a FAA is exempt. Remember these words, exempt from remote ID. Also, you must stay within the boundaries of a FAA, and you cannot fly any higher than 400 feet AGL. Now, the last thing that I need to mention about a FAA that's not usually discussed often, but may be on the Part 107 exam is who exactly qualifies to apply for a FAA? I mean, you can't just walk up to a piece of land and say, hey, I'm going to utilize this area so I can fly my drone without remote ID. That's never going to happen. FAAs are for FAA recognized organizations such as the Academy of Model Aeronautics, AMA, or the FPV Freedom Coalition, or the Flight Test Community Association, ATCA. All of these are what's called CBOs. CBOs are community-based organizations that are involved with FAAs, and all of them are FAA-approved organizations. So you can't just squat down on a plot of land and call it a FAA. Now, there is another way that you can fly without remote ID, and it's not required if you are flying for research purposes. Under the FAA Rules and Guidance, which is 14 CFR Part 89, it stipulates that there is a specific scenario where remote ID is not required, and that is for research. I am specifically focusing on drones being used by government or FAA-recognized public agencies, all of which are exempt from using remote ID when it's in regard to research projects. So basically, we've covered all of the important details in regard to remote ID and what is relatable for the Part 107 exam. But just so we can recap this information so you understand everything in a nutshell, remote ID, number one, is required every time you fly. You have to register your remote ID, and in order to remain compliant with remote ID, there are three things that you must do. You must have standard remote ID built in. You must have remote ID broadcast module if you don't have standard remote ID built in. And if you don't have remote ID whatsoever, the only place that you'll be able to fly with an exemption of remote ID is what's called a FAA. And those three things are what you need to remember for the Part 107 exam when it's in regard to remote ID compliance. Let's move on to the next topic. And this has to do with Visual Line of Sight, or VLOS is the acronym. This is a critical key concept for the Part 107 exam, and safe drone operations depend on it. Visual line of sight, what it means is a pilot's ability to see an unmanned aircraft with unaided vision. You're using your eyes, even if you're wearing glasses or corrective lenses, that is still considered as unaided vision. You're using your eyes to determine where the drone is at all times. And the primary purpose of visual line of sight is to maintain situational awareness and avoid collisions. Situational awareness is your ability to accurately perceive and understand your environment, including your location, the movement, the aircraft, other aircrafts around it, obstacles that may be in the way, hazards that you have in real time happening. You have a situational awareness, almost a 360-degree view of exactly what's going on at every given point in time when the drone is in the air. Visual line of sight works hand in hand with having situational awareness when you're flying a drone. Now, a very important question to ask here is, how exactly do drone pilots apply this knowledge? For a remote pilot, situational awareness involves knowing these few things: the drone's position, the drone's movement, its altitude, its speed, its heading, how the drone's current location correlates to your current position. Are there any manned aircraft in the area or other drones that are flying around? Are there obstacles, trees, poles, power lines, buildings? To avoid these obstacles, you have to have a situational awareness and visual line of sight working both simultaneously at the same time. Now, this is a good time in the video to develop an understanding about Statute Miles in regard to visibility. Now, I could be just like everyone else and tell you that 3 statute miles of visibility is what the FAA requires before you can actually fly a drone legally, but you wouldn't understand what that means, would you? Well, since you know that 3 statute miles is required, let's just move to the next topic. Just kidding. Let me ask you a very simple question. What exactly is a statute mile? And some of you don't know, and you're thinking, I'm so glad he didn't move to the next topic. You see, a statute mile is just simply a regular mile of what you're accustomed to. 5,280 feet. So when you hear 3 statute miles, it's basically referring to an object that's 3 miles away under normal conditions. So let me ask the question that you would probably ask me. Why don't we just say miles instead of statute miles? Well, there's a very good reason for that. It's because in everyday life, a mile is equal to a statute mile. But this is not everyday life that we're referring to. We're referring to aviation. And in aviation, there is statute mile and there's nautical miles. So the FAA does not want to have anything that's confusing. They want everything to be exactly identified, and they hate ambiguity. So they separate the two to make it very clear that statute miles means one thing and nautical miles means something else. So you can't just say miles in aviation. You have to have either one of the two. So since we're on the topic of visibility, referring to 3 statute miles of visibility, let's talk about this. According to 14 CFR Part 107.51c, it says, minimum visibility as observed from the location of a small unmanned aircraft is 3 statute miles. Now, the key word that I just said there was minimum. Let's create a scenario so that way it can be understood. Let's say it's foggy outside and there is a building that's 1 mile away and you cannot see that building because of the fog. Well, it's 1 mile away, and what the FAA is saying to you is that you need to be able to see that building when it's 3 miles away. So the key word is minimum. If you see the word maximum on an FAA Part 107 exam, you better think twice, because that is not the correct word. It is a minimum visibility of 3 statute miles. And since I just mentioned the word minimum, let's drop down to D, where you see the minimum distance that you need to be away from clouds. Let's discuss that briefly. For the Part 107 exam, you always need to remain 500 feet below clouds and 2,000 feet away from clouds horizontally. So here's an interesting question for you. If you are planning to fly your small unmanned aircraft and the cloud ceiling is 600 feet AGL, what is the maximum altitude you may legally fly? And some of you are scratching your heads right now, am I right? But this is very simple. All you have to do is take 600 feet AGL minus 500 feet distance from clouds, and the answer will be C, 100 feet AGL. Now let's talk about something that you'll need when you're flying at night, and those are anti-collision lights that are visible for 3 statute miles. If you're operating a drone early in the morning, 30 minutes before sunrise, or let's say you're operating a drone in the evening, 30 minutes after sunset, those two are considered as civil twilight. 30 minutes before sunrise, 30 minutes after sunset. Civil twilight. You will need to know that for the Part 107 exam. Now, during civil twilight, obviously, there's not going to be as much light as there was during midday. So the FAA says that during this time period, the 30-minute time period, you're going to need anti-collision lights. And those anti-collision lights must be visible for 3 statute miles. Now, there are a few things that are often overlooked when it comes to anti-collision lights, and I'm referring to what's on the exam and also what has been given to you in the study guides. When you have anti-collision lights, the FAA says that they must have a flash rate. They must be flashing. Now, a question that came up recently is, what is the flash rate? What exactly is the frequency of that flash rate? The FAA says that as long as they are flashing at a rate that will avoid a collision, then that's the only thing that they're concerned about. Now, secondly, the lights must be visible in all directions, and you must constantly keep them turned on during an operation. Turning off your anti-collision lights at night would not be a good thing, trust me. Now, for those of you who didn't know, in the far northern region of Alaska, there is about a 2 to 2.5 month period where there is no sunset. I mean, the sun stays above the horizon for 2.5 months. And then in the late fall, midwinter, the sun stays below the horizon for 2 months. So the question I need to break down is, how does civil twilight apply to this situation? Well, when Alaska has no sunrise or no sunset, civil twilight is determined exclusively by the Air Almanac, not by the usual 30-minute before and after rule. And do you see how the Air Almanac is written in the Code of Federal Regulations, but there's no explanation as to what it is? The Air Almanac is an official FAA publication that provides sunrise times, sunset times, twilight times for any location in the U.S. and territories, including Alaska. And the reason it was created and it exists is because standard sunrise and sunset charts do not work well in high altitude areas such as Alaska. So all you people up north, guess what? You're going to need those anti-collision lights strapped onto your drone for 2.5 months, because according to 14 CFR Part 107.29, it is a requirement, and that's the breakdown. And lastly, there was a question that came up on the Part 107 exam that really did surprise me, and this question was, can you dim the anti-collision lights during an operation? Well, surprisingly, the answer to that question is yes, you can. The FAA will allow you to dim anti-collision lights only if it is in regard to the safety of the operation. For example, suppose the intensity of the lights are causing a distraction to other aircrafts, or it may be taking away from your ability to have visual line of sight. These are things that the FAA says that they will allow you to dim the anti-collision lights because of safety concerns. Now, staying on the topic of night operations just for a moment, let's clarify something here. We've already discussed civil twilight, but what is the exact definition of civil twilight in regard to how it relates to night operations? Are they both one and the same? Is civil twilight and night the same thing? Well, the answer to that question is no, they are not the same thing. Civil twilight is referring to the 30 minutes before sunrise and the 30 minutes after sunset. But when we're referring to night or night operations, well, night begins immediately after civil twilight ends. Now, a few weeks ago, someone asked me a question. They said, Mike, do we need a waiver to fly at night? And my answer to them was, no, you do not need a waiver anymore. You see, the current Part 107 exams cover night operations, so that means that you'll be able to fly at night without needing a waiver. Since the FAA updated 14 CFR Part 107.29, night flight is allowed without a waiver as long as the remote pilot complies with the night operations requirements. And we are on point because we're now going to be talking about waivers. And the question is, what exactly is an FAA Part 107 waiver? Easy answer. It's basically FAA permission to deviate from a specific Part 107 rule. But there's a key factor in regard to obtaining a waiver, and that is you need to prove to the FAA that the operation in regard to the deviation will be safe. And not all operations are waivable. There are certain sections of Part 107 that are, let's say, waiver eligible, such as asking the FAA for permission to fly at a higher altitude altitude, or to fly at a faster speed than 100 miles per hour, or to simply request that your visual observer not be required to participate in the operation because they annoy you? Well, that one might not fly, but you get the idea. Those are what I call eligible waivers, but the ones where you're making a request for permission, where the FAA will give you a hard, solid no. They will be examples such as airspace authorization, pilot certification, careless and reckless operation, remote ID compliance is always required. These are just a few that I would consider as being non-waivable. And just so you know, the way that the FAA evaluates and approves these waivers is that they specifically look for operations that are structured in a way where there is risk mitigation. Very powerful words I just said to you. The FAA is looking for risk mitigation in regard to you being able to identify hazards, to have risk analysis, to have operational procedures that have well thought out emergency contingency plans. There is the articulation in your request that states that your crew have been adequately trained for this deviated operation. Do you see how I just gave you the verbiage to justify risk mitigation when it's in regard to making a request for a waiver to the FAA? And if you find a question on the Part 107 exam that's asking you, how do you apply for a waiver? Well, the answer is very simple. Simply go to FAA DroneZone and you'll be able to apply there. There is no fee. The processing time could take weeks or months depending on your request. And keep in mind that poorly written waivers are usually denied. Now, we're at the 1 hour mark in the video, and I want to just take this time not only just to give you a break, but to tell you about my new website, MikeSites.com. If you go there, you're going to find a lot of valuable information, available resources, study guides, downloadable materials, and over 500 test questions to help you pass the Part 107 exam. And the reason why I created this website was so that way you can have the opportunity to chat with me directly one-on-one in regard to those difficult topics or questions that you simply just don't understand. So far, it has been very effective, whereas all of the members who have signed up have gained a complete understanding about some of those difficult topics. And honestly, I've learned quite a bit just from chatting and answering all of those questions also. So with that, let's continue with the FAA rules and regulations in regard to flying over people. So let's start by asking 3 questions first. The first question is, what are the Part 107 rules and regulations for flying over people? Second question, can you just fly over a crowd of people under 400 feet AGL? Third question, what has changed in the new regulations in regard to flying over people? Well, let's talk about it. Old school, new school. Old rule, new rule. Try saying that 3 times faster. You see, in the old days, before April of 2021, the rule was very simple. You could not fly over human beings unless you had one of the 3 things. And before I mention one of those 3 things, let me ask you, do you know why they're saying human beings instead of just people? That's pretty funny, isn't it? That's because the word people has no legal precision. But when you use the words human being, that is legally unambiguous. So therefore, any reasonable person would not be able to misinterpret the meaning of that in a legal setting. Basically, the lawyers wanted to cover their own backsides. They still use those 2 words today, by the way. So let me tell you why it is that you could not fly over human beings before, but what were the 3 things that could allow you to fly over human beings? Number 1, if those human beings were directly participating in the operation. Number 2, if those human beings were under a covered structure. Number 3, if those human beings were inside of a stationary vehicle. Now, that was before April of 2021. It's 5 years later. We're now in 2026, so those older study guides don't work anymore. All 3 of those criteria that I just made reference to were in subparts A and B, but since then they have added a subpart C, which means that you can fly over people if the operation meets one of the requirements in regard to the categories that are specified in subpart D. Now let's go to subpart D and see what they say. And as you can see, 14 CFR Part 107.100, applicability. And this is the subpart D that tells you when and how you can fly legally over people and also over moving vehicles. Now, moving down to 107.105, these are the limitations of operations over human beings. And it basically says that you cannot operate over human beings unless the aircraft, quote unquote, qualifies under one of the 4 categories. Now, looking at category 1, if your aircraft weighs 0.55 pounds or less upon takeoff with everything on board, and there are no exposed rotating parts such as the propellers, and that means that you have propeller guards installed, and also that you will not be having any sustained flight over open air assemblies unless compliant with remote ID requirements. And some of you are saying, that sounded great, but I didn't understand a word he said. Well, let me break it down for you right now. When you see no sustained flight, what that means is that you can't have your drone just simply hovering or lingering or just sitting still. It has to be constantly moving. Now, when you see open air assemblies, what that means is a large group of people, a gathering, an event, something where you have so many people that it's difficult or impossible for them to disperse quickly if something was happening. I'm talking about a music festival, a parade, a sporting event, some sort of political rally or outdoor graduation ceremony or something. Okay, moving to category 2, 107.115. This basically tells you the operating agreements, and it's somewhat redundant because all it states is that you have to be eligible under 107.120A. And if we drop down to that section, it's basically going to give us the eligibility requirements to qualify in category 2. Now, let me stop here just for a moment so I can point something out to you that will benefit you greatly. Do you know why it's so difficult to study for the Part 107 exam? I'll tell you. It's because the information is so sporadic and unpredictable that you just don't know where to go to get an accurate source. This is why it took so long to make this video, because I had to go all over the place just to find the information that's scattered everywhere. Let's go to the Federal Register. But first, pay attention to what's in the Code of Federal Regulations for Category 2. You don't see anything listed in regard to weight. And if you didn't know that weight was a criteria, then you wouldn't look any further. Let's go to the Federal Register, published in 2019, Operation of Small Unmanned Aircraft Systems Over People. And you see in the summary, it says that this is about drones that weigh less than 55 pounds. We're familiar with that. And if we scroll down to Category 2, you see that it says the drone must weigh more than 0.55 pounds. And this makes it very clear to understand Category 2 requirements. And similarly, Category 3 has the same threshold for weight, but with some operational restrictions. So let's resume with Category 2 so we can understand this accurately. In order to be eligible in Category 2, the aircraft, the drone, must weigh more than 0.55 pounds. Now, the thing here is that either in the Code of Federal Regulations, the Federal Register, or the FAA publications online, there is nothing that says less than 55 pounds, even in the FAR-AIM. But you just know that this is Part 107, so Part 107 drones must weigh less than 55 pounds. Also, Category 2 has no greater than 11 foot-pounds of kinetic energy. That will be on the exam. The drone cannot have any exposed propeller blades that will lacerate the skin of a human. I love the way they say that. And you must have MOC and DOC. Now, before I go into Category 3, let me first explain what MOC and DOC actually mean. The means of compliance is for the manufacturer to develop an FAA-accepted method of proving or showing that the aircraft meets the 11 foot-pound kinetic energy threshold. They must submit that testing method to the FAA and then have the FAA accept it. It's basically the way to prove that the aircraft is in compliance. Now, after using the accepted MOC, the manufacturer must declare, or let me interpret that word for you. The manufacturer must announce that the specific aircraft meets Category 2 requirements. And they must submit that announcement, or let's turn it back now to declaration. They must submit that declaration to the FAA. And that is called the Declaration of Compliance, DOC. Now tell me if there's anyone else that would break that down for you. Not going to happen. So now let's move to Category 3. And you can see 107.125 for the operating requirements. And if we scroll up just a little bit, you will see 107.130 that is telling you the eligibility for Category 3. Now, before we go any further, let me tell you the main difference between Category 2 and Category 3. You see, they're both very similar despite the difference in kinetic energy, but in this category, you cannot fly over people unless they are in a closed area and all of them are aware that the drone is flying overhead. Now, the transfer of energy cannot exceed 25 foot-pounds of kinetic energy. The weight is the same as Category 2 for anything more than 0.55 pounds. No exposed propeller blades, and also, just as in Category 2, the drone cannot have any safety defects. The means of compliance and also that they obtain their approval with the Declaration of Compliance also apply in Category 3. And of course, you're sharp already because you can see that there's no mention of weight, but there is a mention of kinetic energy. And everything in Category 3 is exactly the same as Category 2, other than the fact that the kinetic energy is at 25 foot-pounds of kinetic energy instead of 11. Also, no sustained flight and no flying over people who are not under protective cover. And also, for both Category 2 and 3, you will be issued a placard or a sticker that you need to adhere onto the exterior of the drone while the drone is flying in the air. It needs to have that sticker adhered to it. So now let's move to category number 4. And if I give you surface level information, it'll be like this. Category 4 is when you just only need to have an airworthiness certificate. Well, that's important for the Part 107 exam because that's going to be on the test question. But the point of the matter is that you really don't understand what an airworthiness certificate is, do you? And I need to emphasize this with you because Category 4 is one of the most misunderstood categories simply because no one explains it. So check this magic out right now. The regulation Category 4 is governed by 14 CFR 107.140. And what is Category 4? Well, unlike Categories 1 through 3, which is an injury threshold based on the Declaration of Compliance and also kinetic energy, Category 4 relies on the traditional aircraft certification. So this is coming closer and closer to being an actual aircraft, not a drone. It's the category that comes the closest to a traditional aircraft. You see, Category 1 is about weight, under 0.55 pounds. Category 2 and 3 is about energy, injury thresholds. But Category 4 is about airworthiness, which is a certificate that is issued under 14 CFR Part 21. Category 4 operations must be certified. They must comply with Part 47 for maintenance. They must follow Part 91 operational rules. You remember when I told you back earlier in the video about all of these other parts in the FAR-AIM. In this Category 4, the operation no longer feels as if you're flying a drone. It now feels as if you're operating an aircraft. And I can give you a visual impression of the practical reality of this is basically these type of operations are for industrial uses, public safety platforms, advanced cargo systems, and future air mobility concepts. Keep this in your head and remember this. Category 4 is the FAA's bridge between drone regulations and traditional aviation certification. And last but not least, Category 4 does not require the means of compliance or the Declaration of Compliance because the airworthiness certificate takes care of all of that. So now that you're all well versed about operations over people, or human beings, should I say, let's now talk about operations over a moving vehicle. This is 14 CFR Part 107.145. Now you can see this information on screen, but let me read it to you anyway. No person shall operate a small unmanned aircraft over a human being located inside of a moving vehicle unless the following conditions are met. Now you can see the subparts A, B, and C, but pay attention to B where you see that it is only referring to Category 1, 2, and 3. Where's 4? There it is, under subpart C. And do you see how Category 4 has been singled out again, as I mentioned earlier? And at first glance, it appears as though flying over a moving vehicle is similar to flying over people, but that's not exactly the case. There is a subtle difference here that we need to pay attention to. But flying over people and flying over a moving vehicle, you still have to pay attention to the weight, the kinetic energy, the airworthiness certificate. But keep this in mind. If the drone crashes into a person when you were flying over people, that's one risk. But if you crash into a moving vehicle, then the result of that impact could result in multiple accidents. So therefore, you have multiple risks. So it's reasonable to assume that the FAA knows this. So therefore, the requirements for flying over people and flying over a moving vehicle logically cannot be exactly the same. And that's why they have two separate codes. The Code of Federal Regulations has one code for flying over people, and they have another code for flying over a moving vehicle because they are slightly different. If they were not, then they would have put them both under the same statute. So here's the Part 107 Fiesta Resistance that you've been waiting for. When you're flying over a moving vehicle, the same thing applies in regard to Category 1, 2, 3, and 4. You still have to qualify. The aircraft still has to qualify under those categories whenever it is that you're flying over a moving vehicle. This is all set up the same in Subpart D. Those things remain the same for both over people, over moving vehicles. But what was added? What is the limitation now for flying over a moving vehicle? Let me tell you. For Category 1 through 3, under 107.145B, they added that you must be over a closed or restricted access site or not maintain sustained flight over a moving vehicle. Now, the translation for this is that you can pass over the traffic briefly, and you cannot hover over an active roadway. Now, for Category 4, our misunderstood child, it's treated a little differently because they did not add the closed site restriction to Category 4. The FAA assumes that since the aircraft has already undergone certification of flying over people, then those engineering reports, those certifications, the analysis for impact risks, already take into consideration moving vehicles. And there you have it. Those are the slight differences for Category 1, 2, 3, 4, flying over people, flying over moving vehicles, and you're now ready and have the knowledge to answer any question that the FAA might throw at you. And I'd like to ask you to throw something back at me. If you're getting value from this video, hit that subscribe button, hit the like button. Let's boost the algorithm so that way it can promote this video to all of the other people who are trying to pass this Part 107 exam. Now, let's stay on the topic of moving vehicles for a moment and talk about operating a drone from inside of a car, a boat, or even an airplane. And what we're going to be focused on is the remote pilot in command, or whoever may be operating the drone, being either a driver, a pilot, or a passenger. So we'll be shifting our focus now from flying a drone over moving vehicles towards operating a drone from inside of a moving vehicle or an aircraft. And you already knew that I was going straight to the Code of Federal Regulations, 14 CFR Part 107.25, operating from a moving vehicle or aircraft. Now, you can see, as we're looking at on screen, that there's not much information here, right? In fact, I could read this to you in less than 15 seconds. Watch. No person may operate a small unmanned aircraft system, A, from a moving aircraft. Wow, they went right to the kill on that one. Or B, from a moving land or waterborne vehicle unless the small unmanned aircraft is flown over a sparsely populated area and is not transporting another person's property for compensation or hire. Now, most would say, well, that's pretty much self-explanatory, but those are the ones who probably assume that they know the FAA definition of a sparsely populated area, and those words are not words that we use in common conversation. So, you see, a sparsely populated area is a remote location where you'll find very few people, and the population is spread out over a vast area. Basically, you won't find too many people there. Now, we're talking about areas such as the Arctic Circle, the Sahara Desert, Afghanistan. Listen, there are places in those locations where you couldn't find anybody for hundreds of miles. Not too sure if I'd want to be flying my drone all by myself out there, but those are sparsely populated areas. Now, you know I went to the extreme by giving you those examples, but there are areas out here where we live that don't have too many people around. So the FAA says it's preferred that you fly your drone in those areas if you happen to be flying your drone from within a moving vehicle. So we've got that pretty much clarified in regard to the definition of what a sparsely populated area is. But what isn't clarified in the Code of Federal Regulations 107.25 is the remote pilot who's operating the drone. Well, are they allowed to be the driver, or should they only be the passenger? Well, here is Mike doing what he does best, digging. And guess what I found after I dug? Nothing. Absolutely nothing, because there is no code, no statute, no federal regulation. There's nothing in the Federal Registry. There's nothing on the FAA website that makes any mention about a remote pilot having a specific requirement or stipulation of being either a driver or a passenger of a vehicle while or during the operation of a drone. It doesn't say specifically that when you're driving a car, you cannot fly a drone. But the FAA has a way of implying certain things, and they assume that you should know, so they put the implications into two other Code of Federal Regulations. Let me show you what they are. 14 CFR Part 107.19 and 14 CFR Part 107.23. Very important statutes here. Let's go ahead and pull those Codes of Federal Regulations up on screen so you can see it. This is where they have you at no mercy, because even if we could not find the code for a driver operating a drone, well, you still have to comply with these. A remote pilot in command will pose no undue hazard to other people, other aircraft, other property, so and so and so. Next one down, no person may operate a small unmanned aircraft system in a careless or reckless manner. Do you see how they have you there? Because there's no way you can defend yourself when you say, yeah, I was driving my car with one hand and I was operating the drone with the other. Not going to happen. They got you. And the lawyer is going to point his or her finger at you and say, hey, did you have visual line of sight at all times when you were driving that car and operating that drone? And what are you going to do and say? You're going to say, no, I'm supposed to be the passenger of that vehicle, always maintaining visual line of sight at all times. Now that one is allowed, even though you don't see anything about that either. So point well taken. Even though you don't see it on 107.25, the fact of the matter is that you can't operate a drone while you are operating a vehicle at the same time. Okay, let's talk about something else that is implied, not necessarily written into the regulations, and this is drone delivery. You see, there's no specific regulation in Part 107 that explicitly says that drone deliveries are allowed, but there is also no specific regulation in Part 107 that explicitly says that drone delivery is not allowed. And because it's not mentioned, Part 107 allows transportation of property because it never prohibits that, except in one specific situation. And this is tying into what we just went over. You may not transport property for compensation or hire from a moving vehicle. Now let's touch on the points that are allowed for drone delivery. According to the FAA, the operator must conduct the flight within visual line of sight and not from a moving vehicle. The load that's being carried on the drone must be secured in a fashion where it's not going to disturb the characteristic or controllability of the aircraft. The weight of the aircraft with the payload must be less than 55 pounds upon takeoff, and the delivery operation must be conducted within the jurisdictional boundaries of the state. And you can read the additional information below in regard to Hawaii and the District of Columbia. Now, you're beginning to understand that the FAA has a new focus on Part 107 topics. And one of the topics that we're going to be discussing is called Crew Resource Management, or CRM. Now, under the Code of Federal Regulations 14 CFR Part 107, CRM is not mentioned. And that's because remote pilots are mostly considered as solo operators and not necessarily having a crew. For pilots in command who are flying a commercial commercial airliner, and they have a second in command, and then they have a relief pilot, and then they have a flight attendant and a lead flight attendant and a senior attendant. Now those are flight crews, and they all have to go through a mandatory crew resource management training in order to be certified. This is CRM that is legally required only for multi-crew manned aviation under Parts 121 and Part 135. It is not covered under Part 107, but we're going to go over it so you understand why it is that the FAA expects you to know about CRM for the Part 107 exam. Now, when we're talking about a crew for a small sUAS, we're usually referring to the Remote Pilot in Command, RPIC, and the Visual Observer, VO. Let's first talk about the Remote Pilot in Command and his or her responsibilities under Part 107.19. Now, as you're reading these regulations, let me sum this whole thing up in plain English for you so you'll understand it. You see, before a drone flight begins, one person must clearly take charge, and that is the remote pilot in command, who is also the person who is holding the remote pilot certificate after passing the Part 107 exam. That person is also responsible for making sure that the drone is flown safely, it doesn't hurt people, it doesn't damage property, and also that he or she is in a position where they can step in and take control over a drone in case something goes wrong in order to follow the rules and regulations and remain in compliance. Do you see how I just broke that down? And I can clarify on the important points. The overall safety of the flight, ensuring the operation complies with Part 107, making the final decision on whether the operation is a go or a no-go, briefing all of the crew members, the VO, the cameraman, the water boy, ensuring that the drone has been inspected, that it's in perfect working condition and it's airworthy, checking all of the weather conditions and making sure that the airspace that you're about to fly in, that you've been authorized, predicting and circumventing any hazardous conditions and being able to take immediate corrective action if there is a safety risk. Hey, you know, it's not easy being a remote pilot, but somebody's got to do it, right? But the most important thing that you need to remember out of all of this is that if something goes wrong, the first person that the FAA is going to be looking for is the remote pilot in command. So ask yourself this question: what you going to do? What you're going to do when they come for you? You're going to make sure that everything that you're doing is in compliance with FAA rules and regulations for Part 107. Now let's go look for the Visual Observer, VO, and find out what their roles and responsibilities are. The visual observer is the person whose main job is to watch the drone with their own eyes while the drone is flying in the air. Their purpose is to point out any problems or any potential problems that may be happening to the drone, such as people, buildings, helicopters, airplanes, power lines, hot air balloons, anything that may be coming too close to jeopardize the operation in regard to the drone's safety or the safety of the crew, or the safety of anyone else for that matter. It is the responsibility of the visual observer to communicate that. Let me say that again. To communicate that to the remote pilot in command. The VO must always be in constant communication with the remote pilot in command. Now, the last thing I want to say about visual observers is that there can be multiple VOs. For example, you're flying a longer distance on an operation and you need to increase visual line of sight and situational awareness. Or let's say you're flying around a large building and there are many blind spots and you need to increase additional coverage or improve coverage. Or it could be simply that you're flying a difficult operation and maneuverability is tricky. These are some of the reasons why you would want to add multiple VOs to your operation. Now, since we know who the primary crew members are and their responsibilities, let's talk about Crew Resource Management, CRM. And as I mentioned earlier, this is not a legal requirement for remote pilots because the rule does not exist under 14 CFR Part 107. It's mainly just an FAA guideline for information on CRM principles, but it is very important to understand. So let me explain Crew Resource Management to you so you have a complete understanding. Crew resource management focuses on pilots who are operating with a crew environment. But many remote pilots or single pilots who are just operating by themselves can apply these crew resource management concepts to their operations. Now, just for some interesting trivia, back in the old days, it used to be termed as cockpit resource management, and that was focusing primarily only on pilots. But then the evolution of flight attendants, and then maintenance personnel jumped on board, and then there were others. So what do you think the logical thing was to do here? Well, they renamed it from cockpit resource management over to crew resource management. So from there, CRM developed into something that's utilizing the availability of all resources effectively. We're talking about the combination of human resources, pilots, flight attendants, dispatchers, maintenance personnel, air traffic control, by the way, and connecting that to the utilization of equipment, hardware, aircraft system, instruments, tools, and then mixing that with another ingredient of information, data, manuals, flight plans. All of this harmoniously collaborating with each other is crew resource management. And the primary objective is simply to improve human-machine interaction. Now, could I have articulated that any better? Now, on the Part 107 exam, there will be many types of questions that relate to CRM. It will be sort of challenging for you. But the one thing that you need to remember that you can take away from this video is that the FAA does not test CRM as a regulation. They test it as a human behavior. Let me give you a few examples as scenarios so that way you're prepared for the questions on the Part 107 exam. For example, one of the crew members has been drinking and you're not aware of it, but you're informed by another crew member of the situation. What do? This is a matter of making judgment or decision making, right? This is all a part of CRM. Here's another one. You're the remote pilot in command, and your visual observer just happens to see a hot air balloon coming over the building where you're having the operation, and she or he hesitates and doesn't say one word, does not communicate with you. Wouldn't you think that communication is one of the fundamental aspects of crew resource management? Let me give you one more. You've been hired to conduct a difficult operation where the aircraft needs to fly in close proximity to buildings and obstacles. Now, after the briefing that you had with the crew, you remembered that you did not discuss the fact that you're not going to be using obstacle avoidance or GPS on this operation. What do? Do you continue with the operation hoping everyone knows what to do? Or do you hit the pause button, call everybody back, and say we need to have a rebriefing? I think you can see that this video is not just about passing the Part 107 exam. It's about developing your proficiency in the process of becoming a great certified remote pilot. Now, this is a good time to test your retention. I've got 4 questions for you that I want you to answer. Now, I'll give you the answers at the end of the questioning, but what I want you to understand is that these questions have to do with night operations. This is a new topic that they have on the Part 107 exam for 2026-2027. I've been getting a lot of feedback on these questions, so I'm going to ask you these questions so that way you stay fresh, and it really basically just covers what it is that we've already gone over in the video for the past hour. So let's go to this question first. A remote pilot in command plans to conduct a small UAS operation at night under Part 107. Which statement is correct? Look at A, B, and C and choose your correct answer. Don't worry, the answers will be in the video description later. Next question. A remote pilot plans to fly a small sUAS 15 minutes after sunset. Which equipment is required? Pause the video momentarily and write down your correct answer. Moving to the next question. For Part 107 operations, civil twilight is defined as which of the following time periods? Now let me stop here for a moment to alert you to a very sneaky FAA trick. You see, the question is referring to civil twilight, and for both answers A and B, they would be considered as being correct. Let's go for a Mike Sites breakdown right now so I can explain this to you. That beautiful orange glow in the sky that you see after the sun sets or just before the sun is rising is because the sun is below the Earth's horizon, and the horizon is at 0 degrees. So when it's falling from 0 degrees to 6 degrees, or it's coming from 6 degrees below to 0 degrees, the level of the horizon, that time period takes 30 minutes. And that 30 minutes is just one of the stages of twilight that is called civil twilight. Now, when the sun is below 6 degrees, that is nautical twilight. And when it drops below 12 degrees, it comes to astronomical twilight. But we're only concerned about civil twilight, 0 degrees to 6 degrees below the horizon, which takes 30 minutes. So that means that both A and B would be correct. Am I right? Wrong. FAA trick, because the question is asking you about time periods in regard to civil twilight, and it is not referring to the level of degrees. Now, the last question, who is responsible for ensuring a small sUAS is properly equipped for night or civil twilight operations? Now, if I have instructed you well, you already know that anytime you see the word responsible, you know the correct answer. Now we're going to be talking about a topic that's not necessarily new, but it is new on the recent Part 107 exams. It comes from the Pilot's Handbook of Aeronautical Knowledge, Chapter 13, and this has to do with night operations, night vision. The information that we're about to discuss doesn't just have to do with pilots who are flying manned aircrafts, but it's also applicable to remote pilots who are flying at night, and I'm about to tell you why. And as we always do, let's start with the question. Why is night vision different? Well, here's the concern. You see, pilots rely on vision more than any other sense. But here's the problem. At night, your visual system fundamentally changes. And the FAA became aware of this. So what did they do? They created a section for night vision in the Pilot's Handbook of Aeronautical Knowledge. And they highlighted 3 major limitations. I'm about to tell you what they are right now. The first is reduced visual acuity. The second is reduced depth perception, and the third is increased susceptibility to illusions. And all 3 of these limitations are physiological. They're not theoretical. And what I mean by that is that your night vision degrades because of your anatomy and biology and not because of your lack of skill. So let's talk about how the eye actually works by making a comparison to how similar it is to a camera. When light enters through a camera lens, it will be focused on the sensor, and the sensor will convert that light into an image. Now, the human eye will do the same exact thing. How do you think they invented the camera? Easy. They took somebody's eye apart and said, hey, we've got a prototype. Let's build a camera now. You see, the light that we see will enter through our cornea. It will pass through the lens, focus on the retina, and then the rods and the cones will convert that light into electrical signals that will then travel through the optic nerve and then to our brain, so that way our brain perceives it as an image. And you can thank the poor man that donated his eye. The FAA has provided us with images and pictures of the human eye so we would be able to understand the anatomy and therefore develop practices that may improve our flight operations at night. Now, since I just mentioned cones and rods, let's talk about the anatomy of the eye before we actually start discussing the 4 main visual deficiencies that's probably going to be on the Part 107 exam. And keep in mind that this is just a brief tutorial, but you know there's going to be much more information on this channel. Cones and rods are basically light-sensitive cells that are inside of the retina, and it's very similar to what you will see on a camera sensor. Cones, what I'm pointing to right now, are very sensitive to colors and bright light. They're responsible for providing clear, detailed images during the daytime. Rods will see black and white colors, and they're very sensitive to nighttime vision and peripheral vision. They work best for objects that are moving from side to side. So you already have an impression in your head that for pilots and remote pilots, that the rods are the ones that are going to be beneficial for nighttime operations. So for Part 107, during the daytime, the cones are dominant. During the nighttime, the rods are dominant. Now, what the FAA deems as being important will be the first thing on their list, and that is visual deficiencies. And we're going to go over 4 of them right now. Let's start with myopia, and at least you'll be able to learn how to pronounce these deficiencies correctly, right? Myopia is a very common eye problem. It's progressive, it's genetic, it runs in the family, and you'll often hear people say that that's the reason why you're nearsighted. Now, night myopia, which is what the FAA wants you to pay attention to, is a condition where the eye focuses slightly in front of a distant object in low light conditions. This can happen even if you're a pilot that has 20/20 vision during the day. So what's happening for pilots who are operating at night is that since the eye is focusing before the object, then runway lights, for example, appear to be slightly blurred. This is the same thing for remote pilots who are operating at night with a drone that has anti-collision lights and it appears to be blurry. For pilots, this is crucial because night myopia can reduce visual sharpness and reduce the judgment that you have in regard to distance. So wearing appropriate corrective lenses is what will rectify this condition. The next one, hyperopia. And you wonder how they got these names, right? Who made these names up? Hyperopia is a far-sighted condition where the light focuses behind the retina instead of directly on it. And in case you don't know what being farsighted means, well, that's when you can see things that are far away much more clearly than you can for objects that are close to you. Now, just so you know, when you have this condition, it's much easier for the eye muscles to compensate for that difference in vision. But for pilots and remote pilots with this condition who are operating at night, hyperopia then becomes a very important deficiency that you need to pay attention to because it can lead to eye strain, headaches, and there is decreased visual clarity at night, making it necessary for a pilot to wear corrective lenses. And very important, listen to these words. The lights on the instruments in the cockpit can appear to be blurred also, especially after prolonged flying. Let's move to the next one, astigmatism. Now, this is a visual deficiency or a vision condition that's caused by an irregularly shaped cornea or lens. Now, I mentioned both, but the most common cause is an irregularly shaped cornea. This is the covering in front of the eye, and it's usually shaped round, like a basketball, but in this situation, it's shaped like a football. The surface is slightly oval, which causes the light to focus in multiple points rather than directly on the retina. This will result in both objects that are far away and objects that are very close up to appear blurry. And this distorted type of vision may look as if you have streaks or star-shaped lights when you're flying at night. The corrective action is simply that. Corrective lenses is what will be needed to provide sharp and clear vision. And the last visual deficiency that we'll be discussing is called presbyopia. Now, this is something that you'll be able to remember easily because it has to do with old age. It has to do with getting older. So when you get older, the lens that you have inside of your eye becomes thicker, harder. So it's much more difficult for your muscles to actually bend that lens in order for you to focus. Your eye muscles are simply unable to flex the lens because of its rigidity, and you have to hold a newspaper at arm's length just so that your eyes can focus and read the stock market report. For pilots, this can be a very concerning, critical thing because they have to be close up whenever it is that they're looking at the instruments on the cockpit. But for remote pilots, here's where you can understand. You have to hold a tablet or a controller in your hand and you're watching the screen. Well, you don't want to be holding that remote control at arm's length just so you can see where your position is, right? And there's so much more information on this topic, night operations, visual deficiencies, and I will be able to assist you if you go to my website and you can chat with me with these questions that you may have in regard to understanding this topic proficiently. Okay, let's talk about a new topic, new question that's on the Part 107 exam that no other study guide on this earth has covered. That has to do with 14 CFR Part 89.130, confirmation of identification. And I'm giving you a confirmation right now, confirmed that this is on the Part 107 exam. Now, regardless of whether you're a U.S. citizen or a non-U.S. citizen, if you're operating a foreign registered drone within the United States airspace, then according to 89.130, before you fly that drone, you need to submit a notice of identification to the FAA. Now, this notice includes your name, physical mailing address, phone number, email, and also it includes the drone's make and model and serial number and the country of origin and registration number. This NOI, Notice of Identification, that you're submitting to the FAA is what the FAA requires in order for them to issue you what's called a confirmation of identification. It acts sort of like a registration that you have to keep on your person while you're flying your drone, but this is for a foreign registered drone flying within the United States. So when you see this on the exam, confirmation of identification, you will know that they're referring to a foreign registered drone flying within the U.S. airspace. Remember, you must submit the notice of identification first to the FAA with all the information, and then they will issue a confirmation of identification so you keep that on your person while you're flying the foreign registered drone. And if that confirmation of identification is not with you when you're flying, then guess what? You are not flying your drone legally. Now let's move to a topic which I know all of you have been waiting for, and this is the National Airspace System Airspace Classification and Operational Requirements. So let's begin with a question like we always do. What is the National Airspace System with the acronym as NAS? What is it and who exactly developed it? The National Airspace System is basically a network. It's comprised of two types of airspace: controlled airspace and uncontrolled airspace. Think about this for a moment. Every day, there are over 45,000 flights happening in the United States. And within that, there is 29 million square miles of airspace being utilized. Someone has to be regulating this, don't you think? Well, who is it? You already know the answer because you're taking the exam. It is the FAA. And over time, they developed the National Airspace System as a vast coordinated system of airspace with infrastructure and people technology that covers the entire 29 million square miles of U.S. domestic and oceanic airspace. Now, I don't know about you, but it's a difficult task just trying to keep track of 3 kids running around the backyard every day, not to mention the responsibility of keeping track of 45,000 flights. So you can already discern that just as you have safety concerns for your 3 children in the backyard, well, the FAA also has safety concerns for all of those flights within the national airspace. So this is why we have controlled airspace that is regulated by the FAA, and we also have uncontrolled airspace that is not regulated. But don't tell anyone. Uncontrolled airspace is actually regulated. They just don't tell you that it is. We'll talk about all that later, but in this section, we're going to discuss controlled airspace, meaning Class A, Class B, Class C, Class D, and Class E. And then we'll talk about Class G airspace, which is uncontrolled airspace. We'll mention about the vertical limits of all of these airspaces and also when it is that you need to get air traffic control authorization or LANC approval to fly in these airspaces. But before we go any further, we need to discuss something that is the most fundamental concept for the Part 107 exam, and that is understanding AGL versus MSL. If you don't have a firm, solid grip on this concept, it will be difficult for you to understand what you need to know about airspace. Let's begin. AGL versus MSL. Now, I've already touched on AGL previously in this video, but I'm going to go back and reiterate what it is that I mentioned before. What exactly is AGL? AGL stands for above ground level. It is a measure of altitude from the surface of the Earth directly below the aircraft. And noticed how I emphasized the Earth's surface and not the surface of a man-made structure. Anytime you see AGL above ground level, it has to do with something that is relatively ground-based. And this is why the FAA rule for the maximum allowable altitude of 400 feet AGL applies to remote pilots flying drones, because remote pilots and drones are ground-based. For example, if your drone just happens to be flying above Mount Everest, which is the highest mountain on this earth at 29,000 feet, where are you making your measurements for your drone being above ground level? Well, as I mentioned, that reference measurement is taken from the earth that is directly below the drone as it is flying in the air. So the ground, the starting point for AGL for that particular drone is at the top of Mount Everest, and at that point is where AGL begins, and it must be the surface that is directly underneath the drone or directly below the drone as it is flying in the air. Now let's talk about a measurement reference that is consistent, and that is mean sea level. You'll see the abbreviation or acronym as MSL. Mean sea level is the reference altitude measurement of an aircraft's height or an aircraft's altitude above the average level of the ocean's surface. You see, the measurement from the ocean, unlike the measurement from mountains, which are land-based, does not change. It's usually an average level surface, and this is why it's called mean sea level. This form of reference, this type of measurement, is used mostly in aviation, and you're going to see this on sectional charts, airspace boundaries. This is how the pilots communicate with air traffic control. They're using the same form of reference. It's consistent, and it provides a much safer way of navigating through the air because it doesn't change. Let me give you a really cool analogy that I always use. AGL is like being on a roller coaster where the height is constantly changing as the ground rises and falls underneath you. Whereas with MSL, think of it as a train being on a level track, whereas the reference point will remain constant and flat no matter what terrain was beneath you. Isn't that a really cool analogy that you can use to remember this? And it's important to know these differences, but it is much more important to understand why both AGL and MSL work hand in hand together. What I'm speaking of will be on the next video when we discuss about instrument flight rules and visual flight rules, and how the transition period from MSL to AGL takes place in certain classifications of controlled airspace. We'll discuss all of that at a later point in time, but let's keep moving on this video. So here's an interesting question. Why do drones only use AGL if they're flying in the air also? That's a very simple answer. It's because it's ground-based, and it relates to people, buildings, and obstacles. And most importantly, the entire operation of that drone is based on visual line of sight. So you see the differences, but you also see the correlation between the two, AGL and MSL, how they both separately working together. Now, before I forget, you can go to the supplements on my website and look for the phonetic alphabet. This is very important because the NATO phonetic alphabet, also called the ICAO phonetic alphabet, is a critical part of aviation when it comes to communication. The Part 107 exam will test you to see if you know Alpha, Bravo, Charlie, Delta, Echo, Golf. These are the phonetics for all of the classifications of airspace, which we're going to get to later. In aviation, small communication errors can cause runway incursions, airspace violations, or worse. The phonetic alphabet standardizes how letters are spoken, and you will find that both nationally and internationally that these phonetics are spoken the same exact way. So do yourself a favor, memorize the phonetic alphabet as I have, and that will be one less question on the exam that you'll have to worry about. Okay, let's talk about sectional charts now, not being too complicated, too scientific, too difficult. Let's just pretty much just get acquainted and understand exactly what it is we're looking at. This is figure 25 in your Airman's Knowledge Testing Supplement. If you don't know what this is, okay, then a lot of you who already know about this chart, figure 25, understand the complexity of it. This is Dallas-Fort Worth International, probably one of the biggest airports you've ever seen, and I've been there several times, and this airport has 7 runways in total. It includes 5 parallel runways that will run north and south, and there are airports all over the place. I mean many other small airports that are directly under the controlled airspace of Dallas-Fort Worth International. And just by looking at this chart, you can see the complexity already, but what I want to do is to give you a point of relaxation, so that way you can just look at this chart and feel good about the fact that it's difficult, it's complicated, but we're going to talk about it so that way when you see it, you're not going to be shocked, surprised, scared, and crazy. You're going to look at it and say, I understand this chart, because if you can understand Figure 25, you'll be able to understand any sectional chart in the Airman Knowledge Testing Supplement. Now, what I'm going to do is I'm going to point to a figure with that little orange arrow that you're so familiar with. And then I'm going to have a brief conversation about it. I'm just going to talk to you about it and let you know exactly what's going on with it. So that way you can just sit back and relax and watch, and you'll be able to watch this over and over and over again. And eventually you're going to get it. And this is based on a lot of the chat questions that have been coming in on my website. So let's go to the first one. I'm pointing to the airport runway symbol. Now you notice that the color of this is blue. Anytime that you see an airport that has a blue color, no matter what type of runway symbol you're looking at, if it's blue, that means that it has a control tower. Now, every runway that you see on a sectional chart will be oriented in magnetic headings, meaning that it's going to be 130 degrees or 310 degrees or something of that nature. Notice how I just put the picture up, and it's oriented the same exact way as you're looking at on a sectional chart, that it looks exactly the same on a map. Now, when you see the direction that the runways are pointing in, either north, south, east, west, that's going to tell you what the magnetic heading is. It will also tell you what number is on the runway. Do you see how the number is 13? And all you have to do is add a 0 to make it 130 degrees magnetic heading. Pilots know that when they are landing on runway 13, that means they're heading towards the direction of 130 degrees magnetic. And you see I went to the other side of the runway that's labeled with number 31. If I add a 0 to that, it's 310 degrees magnetic heading. Now going back to the sectional chart, do you notice how I'm pointing to these solid blue lines around the airport or around the runways? These are all indications of airspace. So there are layers of airspace around this airport. And since you see solid blue lines around the airport, that indicates that there are many types of layers, all different levels and altitudes and heights. And I'll be breaking all of this down on the next video. But for now, I just want you to become familiar with this particular sectional chart, Figure 25. Now I'm pointing to the altitude limits of the inner core of this airport, and you can see that there's a symbol, FSC, with a number on top. What that means is that this layer, the inner core, begins at the surface, and then it will go up to 11,000 feet. Now, the reason that you know it's 11,000 feet is because when you're looking at these numbers for altitude limits on a sectional chart, you need to add 2 zeros to get the true value. I'm pointing now to the airport information that's always going to be next to the airport somewhere. And within this block, you're going to find the name of the airport, the control tower frequency or frequencies. In this regard, you see DFW, Dallas-Fort Worth International, and the control tower frequencies. There are 4 of them that I can see here. The ATIS frequency is designated at 123.775 megahertz. And just below that, you notice that there is the airport elevation at 607 feet mean sea level, MSL. We went over that earlier in the video. I'm pointing now to one of the outer layers of this Class B airspace and looking at the altitude limits, knowing that the floor of this outer layer begins at 3,000 feet MSL, and the altitude limit or the ceiling will go all the way up to 11,000 feet MSL. This just gives you a brief look, a preview as to what's coming on the next video. It's a big one, 2-hour video, and I will let you know when that video is getting ready to be released. Okay, hold everything. I just got word that there's going to be some new information that's on the Part 107 exam. I'm putting it on screen right now for you so that way you can take a look at it, memorize it. It is the IMSAFE Pilot Fitness Checklist that is going to be on the Part 107 exam, so you need to be aware of this. I will have all the information on the next video. So what we'll need to go over now are the lateral limits for all of the different classifications of airspace, both for the inner core and for the outer layers. Now, the biggest challenge for most people who are trying to teach this is just having a clear understanding of the difference between radius and diameter. The diameter of a circle is radius times 2, or I can say the radius is the diameter divided by 2, and the radius is taken from a point at the center. In this situation, we're referring to the airport. The airport is in the center, so the radius would be from the airport out to the outer edge of that controlled area. Let's start with Class B airspace first. And this is the one, as they say, that is shaped like an upside down wedding cake. The radius of the inner core, which is primarily at the airport, is 5 nautical miles. The outer shelves that you're seeing will extend out to 10 nautical miles radius, and sometimes it can be 20 or 30 nautical miles depending on the particular airport. Remember, you just witnessed the gigantic chaos at Dallas-Fort Worth International. And on this diagram, you can clearly see it's a little bit wider than the others, isn't it? Moving to Class C with 2 concentric cylinders, the inner core will be 5 nautical miles radius, and the outer core, the top shelf, will be 10 nautical miles radius. Remember, we are taking the measurements from the center where the airport is located out to the edge of the control area. So if you see 20 nautical miles on the exam, or anywhere else for that matter, that is not correct because they're referring to radius and not diameter. Class C airspace has an inner core radius of 5 nautical miles and an outer core shelf of 10 nautical miles radius. Moving to Class D airspace, and this one is very simple because the airspace is shaped like a cylinder. There is no outer shelf, so the only answer here is that the inner radius out to the outer shelf at the airport is 4 nautical miles. Class D airspace has an inner radius from the center at the airport out to the outer shelf of 4 nautical miles. And moving now to your favorite and mine, what is the standard radius for Class E airspace? And here's the straight talk. There is no standard. And that's because the surface areas of Class E airspace vary from airport to airport. But just so that they can still be a part of the picnic gathering, the radius is chart specific. Commonly, it's going to be about 4 to 7 nautical miles, but it is not a standardized radius. So how about Class G airspace? What would be the standard or defined radius for that one? Well, we know that it's uncontrolled airspace. We know that it's an airspace below everything else. And you can fly your drone in Class G airspace without needing to get authorization. So here's the answer to the lateral limit. The lateral limit is unlimited. There is no lateral limit. That is until you hit a brick wall, and that brick wall is going to be controlled airspace. Now that just about wraps everything that I know in regard to airspace. If this information was helpful for you, hit that like button and also hit the subscribe button to get the notifications on my next video, which will be a 2-hour video on airport operations, aircraft dynamics, and also something that is not covered on any study guides, even the ones you pay for, is night operations. And that is now something that's on the Part 107 exam. Stay tuned for the next video. It's a big one. Also, go to my website at mikesites.com. Take advantage of all of the free supplements and resources there. It will help you when you're studying for the Part 107 exam. If you have any questions at all, don't forget to post a comment. And until then, I will see you on the next video.